During the time of execution of a program, the process moves from one state to another state. The new state, ready state, running state, waiting state, halted state. So these are the 5 different type of states. This page fault and page table information is maintained by another data structure called page table, which is the data structure that helps me to maintain the information of the execution of current process. Hello everyone, it is Dr. Ravikumar YB, Department of Computer Science, Vidyashram First Grade College, Mysuru, the Temple of Excellence. In today's class, you will be taught about the process in operating system. What is the meaning of process? Let me clarify you that. A program is a static entity. During the time of execution of a program, it becomes a process. That is, it is a dynamic entity. So if that is the case, the process can be defined as a process is basically a program in execution. Please note that these keywords are very important in the examination. If you mention this keyword, that is program in execution, you will get marks. So please see to it. The execution of a process must progress in a sequential fashion, that is one after the other. 1, 2, 3, 4, 5, 6, 7, 8, 9, so on like that. So on like that. A process is defined as an entity which represents the basic unit of work to be implemented in the system, also called as a dynamic characteristic. Of a program is called process. To put it in simple terms, we write our computer programs in the text file. When we execute this program, it becomes a process which performs the tasks mentioned in the program. The same thing as I explained at the beginning, that is, a program is a static entity which is written in text files or in any of the editors. Once it is written, it has to be executed. During the time of execution, the program becomes a process from static entity to the dynamic entity. The same thing is explained here. When a program is loaded into memory, it becomes a process. The same thing. If that is the case, there are different types of states in which the process remains. That is, during the time of execution of a program, the process moves from one state to another state. Which is that state? The first one is new state. New state. Once when the program is ready for execution, that is, when the program is admitted to the queue, it has to be executed by the CPU. During the time of execution of this program, it is placed in the ready queue, is placed into the running state. That is this. It is placed into the running state. That is, we have a scheduler dispatch as well as this. Please note that there is a direction from here to here as well as from here to here. If that is the case, if I consider the direction from here to here, from ready to running state, that means the program is in execution. That it becomes a process. Then this is the third state. If that is the case, that once the program is placed in the ready queue, it is called as the program is ready for execution, but it is not yet started executing the program, so it is in the ready queue. So it is called as the ready state of a process. Once when the process is being executed, it has to be run by the CPU. It has to be executed by the CPU. So during the time of execution of a program, we state that the process is in running state. There is also one more possibility. Suppose if any IO operation is required during the time of execution with some priority of execution of any other process, then it has to be placed in some waiting queue. This is called as the fourth state of a process. once when other processes are executed by the CPU, the first process which is in the waiting queue may be scheduled for ready queue, because the first process is put in the ready queue from the waiting queue. The other process which was pushed into the execution may be delayed, or if it is executed completely, the process which is waiting in the waiting queue has to be brought to the ready queue, so that the process is once again admitted to the running state. So it starts executing. So this is my fourth state and third state. And then finally, when the program is completely executed, we say that the program is exited. The program has been exit. That means it has terminated. So these are the 5 different states in which the process remains. Whether it is a new state, ready state, running state, waiting state, or terminated or halted. We also say that it is halted. The past participle form of halt, that is halted, is the 5th state of a process. So we have to place it in the form of the terminated state when the program is completely executed. So these are the 5 different states in which the process remains during the life cycle of a process. So if that is the case, let me take you to the details of these ready state, running state, then waiting state, new state, and terminated state in detail. New. This is the initial state when the process is first started or created. Then ready state. The process is waiting to be assigned to the processor. The same thing. The CPU is to be assigned to, that means the program is to be assigned to the CPU, so that the CPU starts executing the program to make it a process. Once when they are executed successfully, the process may come into this state after start state while running it by the interrupted scheduler to assign it to other process. During the time of running, once the process has been assigned to a processor by the OS scheduler, the process state is set to be in the running state of the processor. That means during the time of execution, we state that it is in the state of running. Suppose, please note that this is very, very important. During the time of waiting, if there is any program which is in priority, needs to be executed, then the presently running process must be shifted to waiting state. So this is what is explained here. Needs to wait for a resource, such as the waiting state. For example, user input, also called as an IO device or IO queue. Then it has to be placed in the waiting queue. Once when it is brought back to the ready queue, so it is terminated. That means once when the running of execution of a program is over, it has to be terminated. So this is called as the terminated state. So I gave you the explanation of the new state, ready state, running state, waiting state, halted state. So these are the 5 different type of states. Who is going to maintain this information? When one of the program needs to be executed during the execution of another program, the current status of the execution of a program must be maintained in one of the data structure, which is the data structure that helps me to maintain the information of the execution of current process. Process control block. So process control block is a data structure that is defined. It is a software that is defined to maintain the information of current process. If that is the case, a process control block is a data structure maintained by the operating system for every process. For every created process, data structure is maintained by the operating system. Which is the data structure? Process control block. So if that is the case, in short, I will call this as PCB. This PCB is identified by an integer process ID. That means 1, 2, 3, 4, so on like that. So on like that. So on and so forth. PID. A PCB keeps all the information needed to keep track of the process as listed below, which is that the process state. What is the state of a process? Whether it is new, ready, running, waiting, terminated, all these are certain information which needs to be kept in process state diagram. If that is the case, it is in which state of a program execution is maintained by process state. Process privileges, whether the privileges means it allows to access the program for reading or writing or for both modifications and all those things are maintained by process privileges. Then which is the next privilege or the information, state of information? Process ID. Process ID is a unique identifier that is used to identify each and every process created within a system by the operating system. If that is the case, program counter is another important data structure, important data item in a data structure PCB. So it maintains the next instruction to be executed for this process. So that is called as the program counter. If that is the case, CPU registers, there are different types of CPU registers, that is R1, R2, R3, so on and so forth like this. So all this register based information must be maintained by the operating system. So this operating system responsibility is done by the data structure called process control block. So the CPU scheduling information, as I have already discussed with you in previous classes, that is we have first come first served scheduling algorithm, then we have priority scheduling algorithm, then we have SJF, that is shortest job first scheduling algorithm, in which we have preemptive shortest job first scheduling algorithm and non-preemptive shortest job first scheduling algorithm. Then we have round robin CPU scheduling algorithm. All these are different types of scheduling algorithms. Using any of these scheduling algorithms, can we increase the performance of the CPU? Performance of the system is going to be decided by whom? Operating system. So operating system is the one who monitors and checks which scheduling algorithm helps the system to execute the program very quickly so that the resources can be managed among other processes. That means the efficiency, the performance of a program during the time of execution is done by the data structure called process control block, which is also maintained by the operating system. Then memory management information. What is this memory management information? This includes the information of page table. Please note that we have a page table here. Suppose if there is any fault, if you are trying to insert any of the information process into this block, suppose if there are process P1, P2, P3, this is the space for operating system. Suppose if you want to place any of this process, that is P4. Now, if I use P1, P2, P3 are in place, if I use FCFS, which is the first process that is inserted? P1, then P2, then P3. So P1 must be removed from this and P4 must be placed here. Suppose if P1 is already executing and one more P1 comes into the picture, then that becomes a page fault. So this page fault and page table information is maintained by another data structure called page table. So these kind of information, that is fragmentation, segmentation fault, all these are different types of problems which the operating system needs to face, and these are solved by the operating system properly using these data structures. So accounting information, which includes the amount of CPU time consumed. The accounting information also includes the time consumed, the memory information required for the process to be executed, memory required to process. All these are certain types of information. IO status information, this includes a list of devices allocated to the processes. All these are certain type of information. Please see to it here. Process state, this is process state, process pointer, process number, program counter, registers, CPU registers, also called as, in general we can call it as registers, memory limits, list of open files. All these are certain types of information that is maintained in the data structure PCB, that is process control block. So this process control block helps me to maintain the information of a process. So this is how the data structure process control block is maintained by the operating system to maintain the list of processes created until the process terminates. If you have any questions with respect to the topics I have discussed, kindly come back to me. I will be available in the department. Thank you very much. Thank you one and all.